Hello.
Hello.
Is screen visible?
Yes.
Okay, so we'll do underground water tank first. Then we'll see the foundation design. Mm. Length units we take in meter and force unit in kilonewton. Next, finish. Okay. Close this grid. Go to take first coordinate 0, 0 axis. Then select this node. And just give a length with translation repeat in x-axis as a 4 meter. Link step OK. Then select this beam and provide width of 6 meter in z-axis. 6 link step. Then select this beam. In x-axis we give offset of -1 meter at this side and 1 meter in x positive side. Then in z side in -1 meter offset for footing and this side z positive side 1 meter. Go to top view. Select node cursor, select this node. And this node we need 1 meter in x-axis link and in -1 meter in opposite side in x-axis, that is in -1. Okay. Then go to isometric, select beam cursor and provide this water tank height. And height is about 4.5 meter in y-axis, 4.5 meter in y-axis length. Okay. Then select this plate, generate surface mass, select and provide plate first, right here at top. Select all the 4 node, then see it will give you automatic mashing. Mashing means a dividing of plate. So here we have two methods, polygonal or quadrilateral. Polygonal means triangle shape and quadrilateral means in a square shape. So we take a quadrilateral, square or rectangle shape. Okay. And see according to length we 4 meter, 6 meter, 4 meter, 6 meter. So we give a double value here. 4 we give dividation of 8. And in 6 side we give 12 dividation 8 and 12. Apply. Okay. Then just create a small plate here. Quadrilateral 2 dividation here. Then at this point again quadrilateral 8. Then at this point quadrilateral 2 meter. And at this point also quadrilateral 2 dividation means 500 mm of plate size. Length width is 500 mm. Again at this side quadrilateral 411. Okay. 8 2 8 and 2, because we have length is here 4 meters, so we give 8 dividation along with 4 and along with 1 we give a 2 number of plates. Then this side quadrilateral 6, so we give as a 12 meter and 2 12 and 2. Then at this side again quadrilateral, 2 and 8 this side. Select generate plate mesh. Quadrilateral. 2, 4 meters, 8 dividation, 2 and 8. Then next wall, water tank wall. So first point, second, third, fourth, and fifth. Quadrilateral. 4.5, so 9 dividation, 6, 12. 4.5, so 9 double and okay. Here I'll do one thing. I just select all the beams. It's all beams and all the beams and this side only this plate and then beam. Right click and new beam. Okay. Generate surface meshing. Done. Quadrilateral. 9, 12, 9 and 12. Then rotate the view and at this side wall. Quadrilateral. 9, 9 and rotate this side. Generate surface mesh, first point, second, third, first, second, third, fourth, and fifth. Quadrilateral plate, 8, 9, 8, and 9. Okay. Show display whole structure. Okay. Then select the beam cursor and select all the beams and delete these beams. Okay. Now we have only plates, all the plates. 3D view. See all plates we have. Next, for property, go to general and click on thickness, and for footing plate, downside plate, we give as a point head, then 300 mm thickness for wall, add close. Plate thickness, first one is for ground floor, so go to front view, select plate cursor and select these plates, then assign. Done. See, if you press Control 3, you'll see that plate here. With Control 0, we'll see wireframe. Then 300 mm at this portion. Then assign. Done. Then next, support. Click on support and see underground water tank. We give a support as a foundation support. So in see, when you click on create here, so we get fixed pin, fixed butt, but we use foundation. So from foundation, we have to select this one, a plate mat, not footing, plate mat in Y, and we give as a modulus like 1500 or 12. So we give as a 12 with 30 here. We give 120, so we give 20 here for kilonewton per meter by meters. So give this value, add, select, and then select plate cursor, go to front view, select all downside plate, see, and assign this support on plate. Done. Then next for loading, go to load and definition, and we have to provide three types of load. Dead load. In dead load, we give as a self weight and soil pressure and water pressure. So select load case detail, add first load we add as a dead load. Save this project, save, and dead load DL for dead load, add. Then next second number load, no need to select any load here, just give known, select known and specify name as a soil pressure, and third load is water pressure. Add, then close. Select dead load, add self weight load, select this self weight, assign to view on whole structure, select soil pressure. So soil pressure, in soil pressure we give plate load, and in plate load we give as a hydrostatic load. So yesterday we have calculated that soil pressure, that is
1/3 WH.
yes.
12.
So okay, I think it's 26.73.
26.7. 6.7.
Yes, 26.7. So see, when you select the plate load and select hydrostatic, now see, we have to select the plate. So just click on select plate, and then first go to top view and select this third row, because in third row we have the plates. Again, see, just okay, now it's selected, see, and this side is x-axis side, and we have to give a pressure from outside, soil pressure from outside. So this side x is positive, so done. And see, in W1 we give that value 26.7, this one, and in W2 is 0, because soil pressure will reduce at upside. So we give in W1 value, because W1 is a downside and W2 is upside here. So we give this value in W1, and W2 is 0, and interpolate along axis we give Y, but in direction of pressure we give GX, global x-axis. Then add. Done. Then close. See, if you want to see this soil pressure, if you select this soil pressure and click on this tab, see loads. So you can see that load. Go to front view and see that pressure from 40 kilonewton to 0. It's reducing that pressure at upside. Okay. Then for second side, in this axis side, again we have to select this soil pressure, add, and go to plate load again and hydrostatic load. Click on select plate, go to top view, select again this third row. Okay. All plates selected. Other side, click on done. Then at this side, the pressure from outside, so we give in minus this value, because from minus x-axis, so minus 26.7. In y-axis, interpolate global axis, and in direction of pressure in gx, global x-axis. Add, then close. Done. See, if you click, see, we can see that load from front, from both sides, soil pressure from outside. Then next for in Z axis. So for Z axis again, select soil pressure, add, and then go to plate load, hydrostatic load, select plate, and go to top view. Again from x-axis we select this third row. Done. From this side I'm posting 26.7 in y-axis, but pressure in z-axis, global z-axis. Add, close. Done. Then from minus z-axis, from other side, one wall remaining here. So select soil pressure, add, save the project, save, and then plate load, hydrostatic load, select plate, go to top view for select the plate and select the third row, sorry. Okay. This side plate, and then done, and minus 26.7 in y-axis and z-axis. Add and close. Done. Soil pressure we have done. Then next, we have to add soil pressure on these plates, or downside plates, this foundation. On this foundation, outside of this foundation, in top you see this all outside 1 meter foundation soil pressure. Select soil pressure and same as a plate load, and this time you select pressure on full plate, and the load is about minus 21 kilonewton in GY, global y-axis for soil pressure. Add, close. Select this soil pressure and select these plates. Top view, go to top view again. Select plates and these plates. 1 meter we have given offset outside. All plates are selected. Then select assign to selected plate. Assign. Yes, done. Soil pressure on foundation. Then next, water pressure. So water pressure we calculate through height of water tank and density of water, that is 10. So our height of water tank is 4.5. So it's depend how much this water tank fill with water. So suppose water tank is filled up to 4 meters. So we calculate with 4 into 10 the water density. So we get 40 kilonewton that load, water load. So again, water load we give as a pressure. Okay. First I just select water pressure, and first I give to bottom plate, on bottom plate. So for assigning water load on bottom, so you have to select this pressure on full plate, minus 40 kilonewton load of water in GY axis, add, close. Then go to front view, select this plate, isometric, right click, click on new view. So go to top and see how to select that center plate. 6x4. So we have to select first offset, this offset plates. Select first offset plate, this 1 meter. This side plates. Okay. Now how to select? See, we have to select this center place, not outside, but select outside plate. Then go to select in from menu bar, and see we get one option here, by inverse. Click on inverse and see inverse node selection, inverse plate selection, or inverse geometry. So we need to select inverse plate selection. So when you click on inverse, so it will select this center plates, all center plates. Then select the load, assign to selected plate, assign. See, is the water load on center plate. Then click on show whole structure. Done. Then next we have to assign water pressure from inside to outside of this wall. So select water pressure, add, go to plate load again, select hydrostatic load, go to select plate, and again go to top view and select this third row. Done. One plate is selected in Z-axis. Done. This side and done. Now see at this side, now we have to give in negative value because this time water pressure is from inside to outside. So we have to give in negative value, and that is minus 40 kilo. Save the project, save, minus 40 kilonewton per meter in y-axis, but in direction of pressure in g-axis. Right. Close. See, in from front view. Now water pressure from inside to outside here, and soil pressure from outside to inside also. Next, for the other side, again go to select water pressure. Add plate load, hydrostatic load, select plate, top view, and this third row. Select this third row. Selected, done. 40 kilonewton from this side. And y-axis, global, g-axis pressure direction, add, then close. Done. Again in z-axis we have 4 wall side there. Add plate load, hydrostatic load, select plate, go to top view again, select this third row in z-axis. Okay. Done. And this side we keep positive value 40 in interpolate global axis y and direction of pressure in z axis. Add, then close. Now the last wall are remaining here. So again water pressure, add plate load, hydrostatic load, select plate, and click on top view and select this. This side plate is selected, click on done, and from this side minus 40 kilonewton, y, interpolate along y and direction of pressure in G, global Z axis. Add.
We have taken inverse. This should be positive. That should have been a negative.
No, yes, from inside, yes, Z positive and Z negative. All sides we have to give a positive and negative. See, at this side I have given Z positive side. From inside we have to give pressure from inside, no? And at this side we have to give in negative side because it's opposite side. But I just see.
Click on the load.
Okay, so after assigning this all loads, you just analyze this one, analyze and print, add, close, analyze, run analyze and save. It will take. See, go to post processing, apply the deflection according to water or soil pressure or dead load. displacement in summary will get the maximum displacement in y and maximum displacement in z axis. Then next go to plate to see the stresses. So just select maximum absolute. Then go to animation and activate this stress option. Apply. See, these are the stress. Dead load, soil pressure, stresses. And this one. Yesterday I'm not checking these options, so that's why we get an error there. Plate mat. Control with this project. Now just defines property. I just want to use a plate also. Select x-axis being parallel to x-axis and being parallel to z-axis, and click on fill floor grid with plates. Then go to general, define column beam size. 50 by 350 mm by 0.3 for column, and beam we use 0.300 mm to point. Add, then close, and thickness, plate thickness suppose 0.1. Add, close. Select column property and go to select and beam parallel to y-axis. Select all the columns, assign. Then select beam. Go to select beam parallel to x-axis. Select beam parallel to z-axis. Then assign. Plate thickness. Just click on assign to. It will pick automatically all plates. Then go to support options, create support, add fixed support. Select this fixed support, go to front view, select all these nodes, downside nodes, and then assign bottom nodes. Done. Then go to load and definition, and I just add a dead load and live load of this. Dead load, that is DL, and plate, live load. Select first live load, double L. Select dead load, add self weight, member load. Member load is about suppose minus 15 kilonewton in GY axis. Add, then plate load. Plate on pressure on full plate, that is minus 3 kilonewton, and GY axis add, close. Then in live load add one floor load, that is minus 3.5 kilonewton. Height is 15 meter, 12 meter width in length in x-axis, and width is 12 meter in z. Add, and one plate load is also in live load, that is smile. Select self weight, assign to view on your structure. Member load we always assigning on beam. So in X and Z axis, select member load, go to select beam parallel to X axis, select beam parallel to Z axis, then select assign to selected beam, then select plate and plate cursor, select all plates, then assign to selected plate. Live load plate also, select live load plate, select all the plates, and then select assign to selected plate, assign. Okay, then analyze, add, close, analyze, run analyze, then save. Okay, done. So next, after analyzing, see this options foundation design will activate. So click on foundation design and see we have available load is dead load and live load. So use this load for foundation also, include all this load and just click on run stead foundation. Yes.
ज्यादा भूख होगी तो पूरा खा लेगा, कम होगी तो मतलब दो खा सकते।
See, this is our foundation design. So see, this is our bottom support, and just see we have same options here. Menu bar, ribbon bar. In ribbon bar, we get all new open, save as options, and these are for changing view, top view, side view, isometric view, rotation, zoom in, zoom out options here. So just click on top view. See, these are our column position, and now we have to do a foundation designing on this. So see, first we have to create a job. So in StatPro, we'll do 4 type of foundation: isolate, combine, pile, mat, and pile, cap, and mat foundation. So just go to job setup, create new job. See, job setup. In job setup, we get first the job name. Give a job name here. Isolated footing. Isolated footing, job type. See, in job type, we'll get 4 type of footing: isolated, pile, cap, mat, and combine. So we select isolated for single column. And design code, we use Indian code, SI, unit in SI, assigned to all support. And then see, we have available load case, so we have to drag this load case at selected load. So click on these options to include this load. Then just click on create job. So when you click on create job, so we get here isolated footing job here. So click on this plus value, so we get some design parameter of isolated footing. Then again click on plus. See, concrete and rebar parameters, cover and soil, footing geometry, sliding and overturning, and design. So first we see the concrete and rebar parameters here. See, in concrete and rebar parameter, we'll see the unit weight of concrete, that is 25, minimum bar spacing 50 mm, maximum bar spacing. These are the standard value we'll fixed in StatPro foundation already. But if you want to change according to your calculations, so we have that options, just change all this value according to our calculations. Minimum bar spacing, maximum bar spacing, strength of concrete, that is 25, yield strength of steel, that is 415, minimum bar size and maximum bar size. So it will pick minimum bar size as a 6. If you click here, so we see all the bar size are available. So suppose if I want to use 12 mm bar, And maximum bar size 32. So if you want to use this default setting, or if you have changed, so you have to select here set as a default. Just click here and select yes. We want to use these parameters for isolated footing. Just click on yes. Then next go to cover and soil. See, it will show you the diagram also here. It will show the preview also. So in soil and what is cover and soil, we have soil type. See, we have soil type drain or undrained condition. We have two types here, drained condition or undrained condition. Then bottom clear cover, unit weight of soil, soil bearing capacity, depth of soil above footing. How much soil we need for depth of footing, and then surcharge for loading, depth of water table. We have 10 meter here by standard, cohesion, undrained shear strength, and minimum percentage of contact area. Okay, so if we have all these readings, all these parameters from our calculation, so we put all that value here, all this value, depth of soil above footing, surcharge for loading, and depth of water table, cohesion, undrained shear strength, minimum percentage of contact area. We'll put all that parameters here. Then again we'll do yes from here. After giving all the answers, all the parameters, we'll do yes to use the by default. Actually, I don't have any readings about this depth of soil. We get all these readings after the calculations from site. So I am going to use all this standard value. Save. See, State Foundation also give backup message. So yes, then go to footing geometry. So it will show you the footing size or the length and width. Footing type, uniform thickness or sloped. So we have options here too, uniform thickness or sloped. Then design type, calculation dimension, set dimension, fixed width, fixed length. We have these all options for design type. Then minimum length, minimum width, then minimum thickness. Then we have maximum length, maximum width, maximum thickness, all value we have. So for this we need all the calculations for footing. Then plane dimensions, and then thickness increment, and then offset from X or offset from Z axis. If you want to give any offset outside of footing, so we have these two options from both side X and Z. Then length and width ratio is 1. So if you want to use this default, or if you want to fill your own readings calculations, so you have options to click here and change these values. Then just click here and click on yes. Then next option, fourth option is sliding and overturning. Sliding and overturning. Coefficient of friction, that is 0.5. Factor of safety against sliding, that is 1.5. This ratios. Then factor of safety against overturning, we have this all ratios there. Then next last, after giving all the parameters according to calculation, just click on design. So see, when you click on design, it will do design and analyze. Just click on yes. So it will take some time and analyze and show us first calculation. Isolated footing design according to IS 456-2000. See, we have all the footings designed for isolated footing 1. See how many footings we have. We have total. How many footings are there? Yeah, total 125 footings. 125 means that point numbers, downside point numbers. See, these are the footing numbers, group ID, length, width, and their thickness. Then here footing reinforcement detailing, top, bottom reinforcement detailing. Then diagram, isolated footing 1, diagram, section, elevation and plan, footing geometry, column dimensions, pedestal, and all these concrete and rebar properties. We get all these calculations sheet here. And last, you get options for printout also, print calculations sheet. And see, above in geometry, we have these structures. Then in detail and schedule sheet, we get this diagram. Okay, and from here you have options to change that footing diagram according to number of footings here. So see, if you select 31, so you can see 31 footing diagram, elevation and plane. And we have options to save this drawing. If you save this drawing, save drawing as, if you click on it, so it will save in AutoCAD format, in DWG format. If you click here, see, we have options to save in different like JPG, PNG, or AutoCAD. So if you save this in AutoCAD, because in AutoCAD we'll do modification in this footing. We'll do modification. Modification means we give as a drawing title, project name, draw by, check by, and drawing numbers, all this thing from AutoCAD. So save this file in format of .dwg. Then we have GA drawing of that footing. GA drawing. All the footing sizes, we have length, width, and the thickness. Then next we have calculation sheet. This one. So we get all the result above here. Detail and schedule drawing, GA drawing, calculation sheet. So this is isolated footing. Then next is combined footing. Combined footing will do with according to connecting with two beams or two columns or three columns. So then in combined footing, we have the same parameters. We'll see. I just close this one. No need to save. And again, run STAAD Foundation. Yes. Click here, go to top view again, and go to job setup, create a new job, and this time combine footing. Select job type. Select a job type, that is combined. Then design code, we use Indian. SI, include this load, and see, after including this load, just click on create job. So when you click on create job in combined footing, see, we get this combined footing job, but we get one more option here to strip footing. We have to give which column you want to combine. So suppose or what, we have calculated that which columns should be combined or not. So select that columns. Suppose I just select this three column. Okay, select this 3 column, 2 column, 4 column, and then click on create selected node. Create from selected node. Click on it. Now see, we get this combine here. Footing C1, and footing C1 we have support 1, support 31, and support 61. Then next this 3 create. Footing C2, in footing C2 we have this supports, and this side suppose 3, create on selected node. Then from here select this one and this one and add this one. Done. Again I just select this 2 and this 3 at this side and 2 at this. Done. We have given all combination here, and we have total footing C9, 9 footings there. Then go to combination footing, and in combination footing you get again the same parameters, concrete and rebar options. Okay, 25, 50, all the minimum bar spacing, maximum bar spacing, strength of concrete, yield strength of steel, minimum bar size, maximum bar size. And if you want to use a default, or if you give your calculation here, so select this one as a default, yes. Then go to cover, soil, and safety. Again we get all the same options here. Pedestal clear cover, footing clear cover, unit weight of soil, soil bearing capacity, depth of soil above footing, surcharge, depth of water table, and factor of safety against overturn. So just select yes for using this parameter. Then footing geometry. In footing geometry, we get this option: the footing size, their length, and design type. Which type of design we need? Again, calculated dimension or set dimension. If you select set dimension, see we get all the set dimension which are available in this software. If you select calculation, so you have options to modify it and give our own calculations. And then just click on yes to use these parameters. Then click on design. Yes. So again it will design. See, we have now the combination design footing here, and we have total 9 combination. 9 combination footing. See the result summary. The result summary, this combinations diagram, reinforcement detailing, footing, combination footing 1, all the detailings about. We get all this sheet from calculation sheet. In detail and schedule sheet, you get this diagram. Elevation section. See, in footing 1, we have covered 3. And in footing 9, we have covered 2. So it will show you the diagram. At all the diagram from 9 footing. Bar sizes and the spacing. To length is 5.30 meter. GA drawing, we get the GA drawing of combined footing, and here we get this table, size table of FC1, the size, length, width, and their thickness, and calculation sheet. So this is the combined footing, isolated footing, combined footing. Then next is a pile cap footing. How to give a pile cap footing arrangement. Run state foundation again. Yes. Again, job setup, create new job. File. Footing, specify name, and type is file cap. File cap. Design code we use Indian SI unit. Then include this load and click on create job. Now see, in pile cap job we get some options. Design parameter we get same as footing type, like strength of concrete, unit weight of concrete, yield strength of steels, side cover, bottom cover, pile in, pile cap, initial thickness, minimum bar spacing, maximum bar spacing, and then next you get a default to select designing according to this parameter. Then second we get a pile layout. Pile layout. See, pile we get some information. Pile arrangement for support 1. We get all support here, all the support type. Then pile capacity we get just a unit weight, it calculated in kilonewton, lateral 100, vertical 500, and uplift 300. This is the capacity of pile in kilonewton. These are by default here. It's a standard value. Then see the pile dia and the spacing and the edge distance of pile. So if we have any again, if you have any calculation sheets, so we provide all that pile dia or spacing edges and their capacity, all that value here. Then next we get options to calculate the Pile arrangement. See, if you click on calculate, so we get some pile arrangement, and we have minimum 2 pile arrangement to maximum 25 pile arrangement. Okay, from 2 to 25 total pile arrangement. See, 2 horizontal, vertical arrangement. In 3, see, in 3 pile arrangement we have 2 type, this one and this one. And 4 pile arrangement. 5 pile arrangement we have 3 type, horizontal, vertical, and this type in square shape. 6 pile type, horizontal, vertical. 7 pile, we have 4 type here. See. So which arrangement is suitable for structure? We get all this calculation. So suppose I just want to use this 3 pile. This 3 pile arrangement, a case 1. Click on OK. See, when you click on OK, so we get this manual arrangement here, all according to the selecting calculations. Then just go here.
You have to go for every support, no?
Yes.
All the supports.
All the support. I have selected in job all supports. Okay, then go to save the project. Go to pile layout parameter, and here see we get some options here like pile data. We have that lateral, uplift, and dia, and edges, and vertical length. So next we ask for which type of structures we have, rectangular or circular. If you select circular, so it will ask for number of pile and number of layer and pile spacing. If you select rectangular, so it will ask you number of row spacing, and number of column and column spacing. Number of column here and number of row spacing. So number of row we have 1, 2, 3, 4, 5 at this side, and 1, 2, 3, 4, 5 at this side. 5 and spacing is 12 meter. 5 and spacing is 12 meter. Create pile arrangement. Then select current arrangement. Pile arrangement successfully assigned. Show pile reactions. Okay. Done. We have to do only giving spacing there. The structure is spacing. If it's rectangular or circular, we give that. In circular, we have to give number of piles and the layers. In rectangular, we give the number of rows and number of. Then click on design next to analyze and design. So after analyzing and designing, we get this calculation sheet. All the calculation sheet we get, and we get the detailing and of pile here of a single footing we get that. And in GA drawing, in pile case we didn't get any GA drawings. We get only a detail sheet and calculation sheet in pile here. Then see the next one, mat foundation. So run stud foundation again. Yes. Top view, job setup, create new job, mat footing, mat with Indian code, SI unit, and include this all load. Click on create job. Now see we get mat foundation job. Click on it. See we get most parameter like some default parameter here. The unit in thickness slab analysis thickness, slab design thickness we have, subgrade modulus and soil property, beam sections property, pile spring value. These are the parameters of mat foundation. Physical beam table, we don't have any physical beam table here. So see, next in mat foundation, you have to go through with mesh generation. So click on this plus from this mesh generation and see we get add meshing region. So click on plus and see we have some type using polyline, add rectangular region, add circular region or regular polygon. So it's depend on shape, structure shape. So this time structure shape is rectangular, or if it's circular, so we select this option. So we have rectangular shape, so select add rectangular region, and next we have to give a length here, length and width. So we have length is about 12 meter and width is about 12 meter. No need to give y level any. We have, because we have y length and width here 12 meter. Click on add region. So see we get a region here, mat region in blue color. If you select it, it will convert in red color. This is a mat foundation region. Then again we have to mesh. Mesh means we have to divide this region. So go to mesh setup, and in mesh setup select this region and give some identification name. So I just give name of this region as a and add this name here. Select this name and select this region, and then go to generate mesh and see we have target maximum 12, or we have options to in inches or mm or meter. So if you select meter or if you select mm, so it will divide this region in inches or mm or meter. So I just select here in meter. Suppose. Then click on generate mesh and see in quadrilateral meshing or mix quadrilateral and triangle or only triangular. So I select quadrilateral. Okay. See, according to 12 a target in meter, it will mash it in 4 parts. This one. If I give in mm, so it will create more meshing here. So after mesh, then go to analyze and property here. Analyze and property. In analyze and property, we get a slab thickness, that is 300 mm here. If you want to change that thickness, we have options to change this one. Then we have soil property. If you want to use this soil property, tick this one, and we have subgrade modulus, that is 0.040. Soil height, we don't know the soil height. If we have the soil height, just place the soil height here. Then we have this pile spring. So if you want to use pile spring, so you have to use this pile layouts also. You have to first arrange this pile position table. Then you can use this pile spring options. Okay, after seeing this all properties, slab thickness, soil property, go to mat, analyze design options, click on analyze, save. And in mat footing it will take time, and there is error, any results are not available. Okay. Any result is not available means the mat foundation is failed this time. So I just close then run state foundation again. Yes. And this time for mat foundation, I just use combination. There is options to create a load combination for this mat foundation. So because in mat foundation we'll check the stresses on that plate. So that's why, see for a combination, see we have these options, load and factor. Go to load and factor and see we get some options here, generate load combination. Select this load combination. When you click on load combination, we get this tab, a load combination input. Load combination table, we have to select Indian and dead load, live load. There we are giving only dead load, live load. So click on generate load combination. So it will generate load combination here. Then next we have ultimate load combination also. So we do generate this ultimate load combinations also. Close. Here we get this load combination according to live load and dead load. Then next again go to job setup, create new job, specify name mat, and select job type as a mat, and is Indian, design code and unit is NSI, and include this loads combinations and dead load live load, create job. Go to mat foundation, again go to mesh generation, add meshing region, select add rectangular region and specify that length and width. Add region, go to mesh setup, select this region, specify name, suppose mat, and add. Select this name and inches or mm. Suppose if we select in mm, generate mesh or lateral meshing. It will take time to mesh this region. Load and factor again, just create combination, select table as Indian, generate load combination and generate load combination, ultimate load. Then go to job setup, create first job here, mat, select the job type as a mat here, Indian, design code as the Indian, SI, include this load, create top view, mat foundation, mesh generation, rectangular shape, that is 12 by 12 length width, add this. Then mesh settings, select this region, specify name here, add, select this mat, go to generate. This time I am using target 12 inches, generate mesh, then okay, in coordinator, done. In inches, see the mesh. Then go to analyze and property, slab thickness, soil property. Just tick these options to use soil property. Then go to mat slab and analyze this structure once. So after analyzing, we see the output view options, moment envelope generation, design parameter, reinforcement zone, cut slab by line, and moment capacity check. And in mat foundation, we get only calculation sheet. There is no diagram of mat. See, analyze process. So after analyzing, see, you get a calculation sheet, but not from here. At last, see, we have this calculation sheet. If you click on it, so we get the calculation. I think it's analyzing. See, we get this calculation sheet of MAT foundation. From here, you get from last. Save. Go to geometry again. And see, now we have to see the output view options. Click on out view options, and from out view options we can check the stress. Selected stress type. If we select maximum absolute, see the stress. Maximum top stress, maximum bottom stress. We have all the options. Maximum value offset, stress type. Now just click on none. Then go to create moment envelope generations, and moment select current panel is mat by drawing line or slab 0 to 100. Division along longitudinal axis is 60. Division along these are the spacing of envelope. So click on create moment envelope. Calculating stress. These are the spacing of 60 options. Then go to design parameter, and in design parameters we get grade. FY we have 250, 415 or 500. FC we have concrete at 25, and 30, 35, 40, 45 we have all the concrete grade. Then top cover, bottom cover, minimum bar size, maximum bar size, okay, and rebar spacing, and that maximum spacing and minimum spacing. If we click here, we get that bar size also, and rebar spacings, and then click on design. So it will design proceed. Okay. Then next, after design parameter, go to reinforcement zone. So from reinforcement zone, we can check that in which region we have to provide which dia of bar end. So see, in longitudinal top or longitudinal bottom, transverse top and transverse bottom. So if you see in longitudinal top, just click on create zone. So see, when you click on create zone, so it will show as in color, blue, green and red color. See, zone 1 we have to apply 12 dia bar with this much spacing, and in zone 2 we have to give 16 bar dia at this spacing. In red zone we have to give this dia of bar from longitudinal top. And if you see longitudinal bottom, create zone. So we have this bottom, longitudinal bottom, bar spacing and bar size. Transverse top, click on create zone. So this is a transverse top, and we have this bar. So it will display as a transverse and longitudinal up and bottom, top and bottom. Then for see the cut and slab by line. If you click on it, cut and slab, so we can check that moment on this plate. See. These are the moments. See. If I just go to front, you will see this moment in this plate according to load. That is minus 682,361.77 kilonewton per meter square. Go to top view again, moment capacity check, float capacity diagram we have. Float capacity checks. Float capacity check, these are the capacity show as truss. Float moment diagram, these are the moment diagram, moment stress diagram, and we have float failure diagram. According to grade of this concrete, steel, concrete, top cover, bottom cover, rebar size, and spacing. Longitudinal top, longitudinal bottom, longitudinal transverse top and transverse bottom. And then in last you get the calculation sheet.
ये
Okay, so now see the next topic. uh,
कहीं फ्लश नहीं करते हैं
अब चुप करो, new project space, and the next topic is bridge design. So we'll complete today all the bridge design, footing design, because today we have last day. So bridge design. Location same, length unit in meter, force unit in kilometer. Next, finish. Close 0 axis, and width of bridge is about, suppose 20 meter with 5 meter spacing in x-axis. Link step and column. Just select these two node. Specify column in y-axis, and height is about minus. Link step. Then select these beams and go to translation. Repeat in z-axis. We provide a bridge length in z-axis this time, and the spacing about 3 meter. 3 meter, about 20 step, means 60 meter length of this bridge. Link step, but see, if you do link step, all the beams are connecting, but if you select the link now, so it will connect column also in bottom. So if you want to free the bottom column, so check these options, open a base, open base, check this option, then click on it. Done. Select 4 node plate, click on it, click 4 node. Done. Then cancel. Select the plate cursor and select this plate, right click, go to generate plate mesh, quadrilateral of 20. 20, so we give as here, and in 90, 80 and 40, 180. Okay.
Let it be 1 meter by 1 meter.
Yes. Now it's take time to generate mesh. And software is also not responding today. I think this, after analyzing, it will show us that plate shapes are not accurate if is not. So okay, so go to property in general, define rectangular beam or column. So we give 0.4 and 0.4 for beam, 400 mm, and 0.600 and 0.600 for then select 400, go to front view, select these beams and assign this position. Then column, select the column, then assign, and then plate thickness, that is about 200 and assign to view. Then go to support, go to front view, create support, fix, select, assign. Done. Then next, load and definition. See, in load definition, we have to define vehicle load. So select this vehicle definition, add, and now see, we have to specify vehicle type reference. So vehicle type, we have only one vehicle, and the front width of vehicle, we have to specify front width of vehicle. So suppose our vehicle width is about 1.5 meter from front, 1.5 meter, and now we have to specify the load. First load we specify front tire load. So suppose front tire load, and it depends on tire, which vehicles we are using, truck or 16 wheel tire vehicle or 8 wheel vehicle. So
Tire load or axle load? Total
axle
axle
load, yes. So see, the front tire spacing load is about 60 kilonewton. Then second one is at again 60 kilonewton. It will show if I have that image. See, I just try to open Google and show you that load type, the vehicle. See this way. We have to give this spacing is 60 kilonewton, 60 kilonewton in spacing in between on the tires, and we give these loads of all vehicles, but that load will is with this vehicle. So this tire, so we'll assign this loads, and we also give the spacing between these tires. It depends on vehicle type, which type of vehicle we are using. So I'm using this one, that is 1.8 meter from front, this one 60 kilonewton, and there is a gap in between 3 meter there. So I just change the width 8, and from 3 meter 60, and the spacing in between this load is 3 meter. And see, if you want to add more table, just press enter or tab. So if you press tab, so you get a table here. Tab, we get a table with tab. Okay. So just add this vehicle specification here, then close. Then next, after assigning this vehicle specification definition here, go to load case detail, add, and see here, no need to add any primary load, just click on load generation. So how many load you want to generate? So our bridge length is about 60 meter. So I want to generate 60 loads there. 60 means at 1 meter I want to see the load. So 60, and predefine, here we not need to give any options. There is none. Just click on add, close. So after adding this 60 load generation, select it and add. See, when you select this generate load, we get these options: new load case, load generation. In here we have to give initial position of load and load increment. So we have to see load increment in Z axis because our bridge length in Z axis, and I want to see increment at 1 meter. 1 meter. Then next we have to specify the vehicle position. So our bridge width in X axis. So I have to, and the total bridge width is 20 meter. So I just give a 10 meter half here to put, by place a vehicle at center of this piece. 10 meter. Click on add, close. See, we get this type 1. See, if you click on type 1 no, so you can see that vehicle symbol here, this vehicle symbol. Okay, vehicle. After analyzing, we get all 60 loads there. Okay, after analyzing, we get all 60 loads. We have to assign only this 6 load generation, 60 load generation, or it depends on length, bridge length. Then vehicle type. Vehicle type is vehicle position in x-axis and load incremental in z-axis. Okay, load generation. After that, if you want to give any load, dead load or live, just see dead load. See, we have the load number 61. Why? Because we have already given a 60 load generation there. DL, add, close. Select dead load, add self weight. Select self weight, assign to. Done. Go to analyze and print, add, close, analyze, run analyze, and see how many errors. Okay. So analysis done. Then see, go to post processing. See, we get all the loads here, 60 loads. Okay. Then go to front view, not front, in left view, because length in Z axis. So just click here and see, we get all 60 load generation. See, click on load generation and activate this share in y axis and moment in y axis. Go to result and options report results. We have that options view is value, dim result, maximum bending and maximum share or maximum displacement, and it will display all result, view value, remove that. See, now our vehicle position at this point in load number 1. So just click here and scroll mouse cursor. So it will see the vehicle is moving at 1 meter, and we'll see that all the shear and bending moment. See the vehicle movement. See in plate load also. See if you click on plate load, click on maximum absolute, apply, OK. Then see in isometric, see the vehicle positions is here. See if I move this vehicle from here at 1 meter, see this is. Just scroll your mouse here, because we have all load 60 load here, 60 meter load at 1 meter. So this is the vehicle moment. If you scroll mouse here, so we'll see the vehicle moment on it. See, go to modeling, general. In right or left view, go to load and definition, activate this vehicle position. See, we have this vehicle and this load. Activate this shear force and bending and deflection, and just click here and scroll mouse. So we see the moment of vehicle from at 1 meter. See, load about 60 kilonewtons with shift B. Then this is what. Minus 20, minus 40, minus 60 kilonewton load. So this way we do our moving load on this in stat. All 4 type of foundation, moving load, and bridge design. Practice this all topics, and if you get any doubts, so message in group. So we solve all the problems.